Question 28. An aqueous solution of desiccated ferrous sulfate was prepared by adding 41.5 grams of ferrous sulfate to enough water to make 1,000 ml of solution at 18 degrees Celsius. The density of the solution is 1.0375 and the molecular weight of ferrous sulfate is 151.9. What's the respective molarity and molality of the solution?
We've gotten the number of moles as 0.273 moles, and that those number of moles is in the one liter, so that's basically also the molarity. Then for the molarity, it's moles per kg, and the moles is 0.273 moles. Then for the weight of the solution, it's 1,000 ml multiplied by the density, which is 1.0375. So you get the weight of the solution will be 1037.5. So you have that divided by, to change into kgs, it will be you divide. Yeah, because you have, yeah. because you will get 1,000 mLs times the density. The weight you get is in grams. So you convert
Your voice is breaking.
that to kgs. How many kgs do we? Oh, okay. So I said we get, yes, we've gotten 1.037 kgs. Yeah, so you get 0.263. No, that's what I've gotten as the molality. The 0.263, that's the molality, which then for me 0.27 was the closest thing I could for molality. So that's how I arrived at C.
So is that okay for everyone?
Yeah, that's perfect. Yeah.
Okay, so for 20, it's C. Can you go to the next question? Like 227 is the next one. So all of the following analytical methods are used to determine the amount of drug bound to a protein, except solvent-solvent extraction, equilibrium dialysis, ultrafiltration, and gel filtration. Yeah, so from Google, protein binding may be assayed using equilibrium dialysis, ultrafiltration, gel filtration, and ultracentrifugation. Yeah. Can we go through each of them, or should we just move on for the assay methods? So Hiral has sent the methods to the chat box. I hope that's enough. Question 226. All of the following statements about binding of drugs by proteins are true except the binding may facilitate the distribution of drug through the body. The binding may inactivate the drug by not enabling a sufficient concentration at receptor sites. The binding may facilitate the excretion of the drug, and the binding may lead to formation of a drug protein complex, which itself is biologically active. So which of the following, so which of the statements is not true?
C.
Yeah, so C is the right one because the drug binding to the protein will not promote excretion. We can move on to the next one. So yeah, Abigail is saying she thought only free drugs are active.
Excuse, I'm wondering, renal excretion is not usually facilitated by glucuronidation of some drugs.
Glucuronidation.
See, now, oh no, that's not a protein. Okay, sorry. So, understood. Yeah, I had just confused. Like I thought if glucuronic acid was a protein, then like binding to it usually facilitates renal excretion or mini steroids. So I just but you're right. So yeah, protein binding is usually for
Okay, so what do you think of choice D?
the binding. Yeah, like so. Basically, the question is just saying like proteins in themselves. Once they bind to these drugs, first of all, they can increase the distribution because then they're more lipophilic into the protein, and they're more, like they due to binding, they can move better, and then also the complex themselves with the proteins might sometimes make the drug more active, and sometimes also they might generally inactivate the drugs. So I think it's fine. Or what were your thoughts on it?
So we go with choice C.
Yeah, Tracy.
Okay. So Gaius has said he thinks excretion is the best answer because when drugs bind to proteins, they can't be filtered. But B also seems right.
I was thinking for D, it could be right, but then also when we say biologically active, maybe sometimes like the proteins can increase the activity of drugs in that due to them binding to the protein, they sort of act as an accumulation of the drug or as a drug depot, therefore allowing the drug, almost like a sustained release of some sort when they're bound. So just generally, they'll increase the concentration of the blood present, the concentration of the drug present within the body, and therefore increasing its biological activity.
Okay. Or maybe we can put a star on question 226 and move on to 225. If the pH of a solution is 4.72, what is the hydrogen ion concentration? Negative. At Sunshine, could you explain to us how you arrive at D?
The pH is negative log of the concentration of hydrogen ion. So if you do the anti-log of negative 4.72, that's what you end up with. Is that okay, Hasna?
Yes, Sunshine.
Okay. That's okay.
Yes, that's okay, but you are too fast.
Oh, pH is the negative log of the concentration of hydrogen ions. So if you do the anti-log of negative 4.72, you end up with answer D. Hasna.
Yes, Edith. Thank you.
That's not my name.
Okay, Sunshine. Are we all okay with question 225? Okay, question 224. In the reaction, ethanoic acid plus water, what do we get?
I think the question is asking in the reaction, which is the Bronsted-Lowry-Wick base in the following reaction. So you're given this, so you have to figure out.
Pardon, which is the best?
which is the Bronsted-Lowry weak base in the following reaction. So you have this is what it's what?
Ethanoic, right?
Yeah, ethanoic acid. It's not the full, it's just the conjugate base plus
Yeah,
what
yeah.
gives you the hydroxide ion and ethanoic acid. So we're supposed to find which is
Okay.
the weak base.
Okay. What's Bronsted-Lowry definition of a weak base? Of a base?
It donates, it's a proton. No, it's a donor. No, acceptor.
Yeah.
Acceptor. For areneous acid, it produces the hydrogen ions. For areneous base, it gives hydroxide ions. For Bronsted acid, it's a proton donor, and for the base, it's an acceptor.
That's for Bronsted. This one here. Proton donor is the acid.
Yeah.
What about Lewis?
Lewis, I can't recall for Lewis.
Asmahan, do you mind telling us?
Lewis acid is it forms a covalent bond by accepting an electron from another species. So it accepts an electron pair, sorry. And for the base, it donates the electron pair.
Okay. You had said for Arrhenius.
Yes. Shina had said for Arrhenius.
Please pardon. Oh, please repeat for Arrhenius.
Arrhenius,
Okay.
it gives the hydrogen ions, proton, H plus. And for the base, it will give the OH ions.
Okay. Then it's the summary of the Arrhenius, Lewis, and Bronsted has been sent to the group, so you can look at it. So what will be the answer for question 24? Do we all agree it's B?
Yes.
Okay.
Excuse. If the reaction is going both ways, why can we also say that C is a proton donor? Yeah, can we also say that trace C is a proton donor? If you're breaking, whoever is talking.
No, I think that is an acid. That's a strong acid. So if you have a strong acid, you'll give a weak base, a conjugate base.
Oh, weak base, okay.
Yeah, so for like here, H2O is a strong base, so it will give
Because
no. Water can act as an acid or base. So if this is the base, it's going to sorry, I'm confused. I might confuse you. Not
Yeah,
Just
but I think what
really,
this is it's ethanol or what?
you see now we said that B is the Bronsted-Lowry weak base, yeah, which is the one that accepts the protons, right? So in this equation, C would be now the conjugate base.
Oh, okay.
Yeah. Sorry, the conjugate acid.
Yeah, conjugate acid.
Acid, yeah.
And then A would be the conjugate base.
I think we just look at like B and C. I'm not sure about A and D.
Oh,
yeah, if the reaction is going backwards, the hydroxide ions will be the conjugate base.
yeah. But everything, even the CH3, COOH is also a weak acid. So the way Srina you're saying
That's the
it's
conjugate acid in this reaction.
not, yeah, but yeah, it's not a
For the OH and the CH3COO, won't the OH be a bit stronger than the other one, than the B?
I don't know. I just think that I think they'd be the same because the reaction is at equilibrium. So I think on both sides they'd both be weak to the same extent. Like the reactions would sort of be the same because they're all in an equilibrium.
Okay, so we are going with choice B or A. Asmahan, do you mind explaining why it's B? Asmahan,
Yes, Hasna.
why
It's
is
B
it B?
as explained, yeah, because an acid is a proton donor and a base is a proton acceptor, in this case in Bronsted-Lowry. So the ethanoate anion will accept a hydrogen ion from water and then now forming the hydroxide. Then the hydroxide will lose the hydrogen. I mean the water will lose the hydrogen now, yeah. Or rather donate the hydrogen, making it an acid, like a proton donor. Yeah.
Yes, thank you. Question 223. Prior to administration prior to administration, enema should be kept at
Body temperature.
Okay, yeah, so body temperature.
and the storage of enema is at what temperature? Just as a general storage.
Probably room temperature. Yeah, Gareth have confirmed it's room temperature. The question asks prior to administration.
It is room temperature. According to me, it's room temperature.
Okay, kindly explain why it's room temperature.
If you put NMRs are manufactured to melt at body temperature. So if prior to administration you put it at body temperature, it means it will melt before it gets to be administered. So it should be kept at room temperature. Then when you administer, it will have to melt after it comes into contact with the body temperature. But prior to you put it at body temperature, it means you'll not administer anything. You'll just have to administer the fluid because it will have already melted.
Excuse me, I thought enemas are already liquid.
Come again?
We had said earlier that enema is a liquid.
In terms of standard instructions, before, so what they're saying, let me just read them out. It's saying fill the enema bag with your desired solution using warm water. Make sure the clamp is shut. Hold the bag with the hose end down and open the clamp for a moment, also to get rid of air bubbles, since you don't want any air bubbles. So I think just before, we usually mix with warm water, and then that's when you give them. So personally, I think it should be body temperature.
Your room temperature might be a bit low.
Yeah, that's what I'm thinking.
Okay, in the group, someone has sent for explanation. It's stored at room temperature prior to administration. It's not storage. It's prior to administration.
Yeah. What we can say is literally just before the patient is given, you tell them to warm a bit. But when it's at your pharmacy, you just place it on the shelf. Simple as that. So that you don't spend too much time there on a question that is perhaps just ambiguous a bit.
Okay, so room temperature is for storage, body temperature prior to administration. So the correct answer is B. We go to the next question. Oh, correct question 23 to body temperature. Then question 22. If a bottle of tablets has an expiration date of June 1999, the pharmacist may yeah, I thought it has up to 3 months. So dispense the tablets through June 30th, 1999. Yeah, or dispense up to that. Question 221. The USP specification. Yes.
Please repeat explaining the previous question. 222.
I was told, like, after the expiration date, you can use the medicine up to 3 months, of course, except for tetracyclines. Yes, but if you give the patient an expired drug, he won't understand. Sorry about that. But yeah, you can, it's safe to use the drug up to 3 months, but if you give the patient, they won't understand. So yeah. Is that okay, Lydia? But anyway, guys, I said 3 months Nikwa streets, but okay.
Yeah,
They
just
may-
on that, there was a study that was done and it was shown even up to 10 years, the drug still maintains 90% of its potency. Just that you can't sell an expired medication.
Very true.
Yeah. But otherwise, the drugs are tough, except now for the tetracyclines that have a specific adverse reaction.
Gaius,
Yeah, what's up?
what's the adverse reaction of tetracycline that occurs after the expire?
That Fanconi syndrome affecting the kidneys.
So it gets worse
The metabolite we said yesterday, was it yesterday? Like they form the inactive complex which are toxic to the kidney, the AP and hydrotetracyclines.
Oh, okay. Thank you, Lydia. And Gaius,
It's not anhydroepitetracycline.
Okay, from my notes, I saw it's AP and hydrotetracycline, which is toxic and inactive. So as much as when you give the drug past expiry, the metabolites that are formed are inactive and still toxic to the kidney. So there's no need of giving them.
Okay, so AP anhydrotetracycline, not anhydro AP. Okay.
It is AP and hydrotetracycline.
Okay, thanks, Linda. Can I move on? The USP specification of a cool place include the temperature range of. No.
Was it D?
Yes.
Question 20. The non-aqueous vehicle used in injections is. Vegetable oils. Okay. Can we go to the next one? Dispensing of carbonates and bicarbonates along with acid or acidic drug is an example of
chemical incompatibility.
okay. Do we need an explanation for that, or we can move on? Do we agree question 219, it's chemical incompatibility? Okay, can we move on? Is it because they'll form the salt? Negative 12 degrees Celsius is equivalent to how many Fahrenheit?
Paris boy.
Yeah, so I see to convert from degrees to Fahrenheit, you multiply by 9/5 and then you add 32.
But there's no answer.
Yeah,
I got
so you
10.4.
It's B.
I got B. Maybe you forgot the negative.
It is B.
Lydia, what have you gotten?
Hello.
Yes,
I said I got option B as
10,
the
10.4.
10.4.
Yeah, if you use degrees
The formula.
Celsius times 9/5 plus 32.
Yes, yes.
Okay. If I didn't ask you and asked Lydia, it's because I don't know who had said the answer. So sorry. Question 217. Oh, I was not dismissing you, that is. The next question. A physician places a patient on a daily dose of 48 units of UAT insulin. How many ml should the patient inject each day? How do you work out question 218, 217? Okay, we can write the formula and then we move on. Okay, so 0.6, B is the right one. Yeah. And then Patel is asking about 2/3 and the third for insulin. Anyone who can shed light on that?
I think the higher ratio is for like morning hours and then yeah, as Gaius has said.
Okay, thanks. Why did you think it's A, B, C? U80 doesn't like mean 80 units in 1 ml. Yeah, U80 means 80 units. Okay, 80 units in 1 ml. Who can reach out to Patel? Should I share my screen and then we'll mark the correct ones later? The amount of sodium chloride. The amount of sodium chloride in 10 alpha liter of a 1 m solution is who knows the answer to that one? Oh, when Patel comes back, she can tell me to stop sharing the screen. Oh, guys, do you mind explaining what it means?
Okay. So molarity we know is moles over volume. So this solution is 1 molar, and we know it's moles over volume in liters. That means 1 mole is in 1,000 ml, or 1 mole is in 1 liter, or 1 mole of sodium chloride will be in 1,000,000 microliters. So what about 10? 10
I have a
microliters.
question before you proceed.
Uh-huh.
The unit for those, is it 10 microliter or what is it? The first 10? Sodium
Yeah,
chloride?
me, I've seen as if it's microliters. I've worked it out in microliters.
Okay, that's okay. Thank you.
Yeah, so 1 mole of sodium chloride is in what? 1 liter is in a million microliters, right? So what about in 10 microliters? So you'll do 10 divide a million, you get that it will be 1 times 10 to the power of -5, right? 1 times 10 to the power of -5. So again, you'll say 1 mole is equals to the molar mass. The molar mass of sodium chloride is 58.5 grams. What about your wire? What about that 1 times 10 to the power of -5? You multiply, you get 5.85 times 10 to the power -4 grams. Converting it to milligrams, you will get the 0.585 milligrams. So in short, it's you get the number of moles in the 10 microliters, then you convert those moles to mass. Yeah.
A pharmacist has 50 ml of 0.5% gentian violet solution. What will be the final ratio strength if the pharmacist dilutes this solution to 1250 ml with purified water?
Okay, I'm saying DD. So I'm thinking, but again, mi sijuangi formula. So a pharmacist has 50 ml of 0.5% gentian solution. So it means in that solution, in a 0.5 ml is in 1,000. 0.5 ml is in 100 ml of the solution. So in 50 ml, then you'd have 0.25 ml of gentian. Then the 0.25 is now what is dissolved in 1250 ml. So 0.25 to, in the ratio is 0.25 ratio, that's 1250. Then now you write your ratio in the simplest form, you get, I think, D.
Kindly repeat.
I was saying 0.5% means we have 0.5 mLs of gentian in 100 mLs of a solution. But then we only have 50 mLs of that solution. So what's the volume for our gentian? Then we get it's 0.25 mLs of gentian, which is what is diluted to 1250. Then you write that as the simplest ratio. I think someone has sent it in the chat. I don't know, or maybe someone else can explain, that data makes sense. Percentage of the
The formula is on the chat box. So after getting 0.25, you ratio it with 1250. So 0.25 to 1250. That's how you get 1 in 50,000. Is that okay, Hiral? Is Patel back? Okay. How many grams of 2% aluminum paste must be mixed with a 10% aluminium paste to prepare. Oh, okay. Abigail is requesting someone to repeat question 216. Abigail is, have you seen what Gaius has typed? Okay. So question 214, how many grams of 2% aluminium paste must be mixed with a 10% aluminium paste to prepare exactly 120 grams of 5% strand?
Can I answer?
Yeah. Oh, should I type or you'll type on the group chat?
I don't know how to type, but I can take you through.
Okay. Then let me type.
Using the allegation method, Hello?
Yeah, I'm getting you. What's the allegation method?
Where the concentration that we need, which is 5%, should be in the middle. Then you take 2% and then you put 10% below the 2, and then you cross in between the 5. The 5 to be in the center.
Yeah, so the 5 is in the center.
The 5 will be in the center.
Yes.
Now you cross from 2, you cross down to 5, you'll get 3. It's like you take 5 minus 2, you'll get 3.
Yeah.
And then from 10, you cross to 5 again, you'll get 5. It is like 10 minus 5, you'll get 5. You getting it?
Yeah, I'm getting it. That's what you mean, right?
Why is the 10%?
Like this is I'm getting there.
Okay. Yeah, there. Good. Now you come down below the 2.
The 10
No.
should not be up there.
No, mine is down.
The 10. Oh, the 10 should be down. Okay.
10 should be down. Beside the 3, below the 2, below the 2. Opposite the 3, below the 2, opposite 3. Yeah, there. You cross upward, you'll find 10, 5. Across on top, across top. The 3 was okay, yeah, Apple. Right there, 5. So it is 5 all over 8. You'll take 5 plus 3, it is 8. So it will be 5 all over 8 for 2. And then for 10, it will be 2 all over 8. So that one, 5 all over 8 multiplied by 120. Times 120, you'll get 75. That is for the 2%.
You're taking 75 grams of the 2%.
Exactly, that is the answer, because they have asked how many grams of 2% aluminium. So you'll take 75 grams of 2% aluminium. If they could have asked how many grams of 10%, you could have taken 45. Because if you multiply again 3 all over 8 times 120, you'll get 45. For the 2%.
So for the 2%, you're taking this 5 and this 3.
Yeah, ni kama kusema 5 plus 3, the total of them, the 2 of them, it is 8. So for all of them, it will be divided by 8. So itakuwa 5 all over 8 and then 3 all over 8 times 120 both.
Okay.
That's the answer, 75 of the 2 grams. I don't know if anyone has got this another answer, but that was the answer.
Okay. Can you do it on a paper and send to the group?
Exactly. I'm doing it.
Okay. Patel, can you reshare your screen? Can you start sharing your screen?
Yeah, sure.
Okay. Ni vigumu kama she'll send the calculation to the group. Is that okay, ABC? Oh, so Patel, we had done the others. Will you mark the answers, then we go on, or you'll mark later? For 215, we got D.
Yeah.
Okay.
You just
So,
said
yeah.
I'll write how to do it later there. I figured this one out.
Okay.
This is the right answer, right?
Yeah. So 214, we can go to 214. Yeah, we've gotten 75. Then now question 213. Sufficient water is added to 800 ml of a liquid chemical. The density is 0.8 grams per ml. To make a final volume of 4,000 ml, what's the percentage weight in volume concentration of the liquid chemical in the final preparation? Oh, Hirala sent the calculation into the chat box. Strong iodine solution, USP, contains 5% iodine. How many milligrams of iodine are consumed daily if the usual dose is 0.3 ml TID. So 5% weight in volume of iodine. How many milligrams of iodine are consumed daily if the usual dose is 0.3 ml TID? So 45 milligrams, because we'll do 5 grams are in 100 ml. So we will find how many grams of iodine are in 0.3 ml, which we are getting 0.045 grams, and then that gives you 45 milligrams. Patel, can you go to the next one? The working there on the question is right. So we can use that one. So for 211, Lanoxin pediatric elixir contains, for 212 we've said 45 milligrams. Lanoxin pediatric elixir contains 0.05 milligrams of digoxin per ml. How many micrograms are there in 3 ml of the elixir? Okay, Hiral, you can explain. Patel, are you still here?
Yeah, I'm back.
Okay.
So they've said the 0.05 mg is per ml, and and they're asking for how much is it in 3 ml. So if 0.05 is in 1 ml, then how much in 3 ml? Then whatever you get, that's in micrograms. Sorry, in mg. So how much would that be in micrograms? So you multiply that by 1,000 and you get 150 micrograms.
Okay, thanks. The boiling point of alcohol is 78 degrees Celsius. the corresponding temperature in degrees Fahrenheit is. So we said you take the degree Celsius, you multiply by 9/5, then you add 32. We'd already done that. So you get 172 Fahrenheit. How many? How many millimeters of our 5% stock solution should be used to prepare 4 fluid ounces of 1 to 200 solution? Can someone explain to us question 209?
Hello,
Yes.
Hasna.
Yes.
I think that question you use the formula C1 V1 is equal to C2 V2. So the 5% will be the concentration 1, and we don't have the volume. And then for the C2 it's 1/200. So you convert you convert 1/200 is the concentration 2, and then 4 ounce is the volume 2. So I don't know 4 ounce into ml. Yes.
1 ounce is in 1 ounce 28 ml. Gaius has gotten 11.2 ml.
And I'm being told that 1 ounce is 30 ml. So if it's 30 ml, then it will be 12 ml.
Okay.
Yeah.
So what do you say we do 1 divide by 200 times 120?
No, I'm assuming okay, what I did is one gram in 2000 ml. So what about, because percentage, it has to be in 100 ml. So you will find what is in 100 ml. So it will be 0.5. The C2 will be 0.5, not 1 gram. 0.5 in 100 ml. And then the 4 ounce, you multiply by 30, the way it has said. So it will be 30 times 4. You get 120, right? So it will be 0.5 times 130, 120, I mean. Is it 120?
Wait, how do you get 0.5?
The concentration to the second concentration, it is
Oh,
the
just
ratio
correct.
1 to 200. When calculating the concentration, is usually as percentage, it is usually in per 100 ml. So it's like 1 gram in 200 ml. What about 100 ml? It will be 0.5 grams. Is that okay?
Yeah.
So you'll multiply 0.5 times 120 divided by 5. So you get 12 ml.
Hydrophilic petrolatum contains what as an emulsifier? Google is saying sodium lauryl sulfate, and it's not among the choices.
Somebody is saying that we continue from 8 from here.
Oh yeah, that can be
So
our
do
last
we,
question,
so
right?
do we start this question or what do we do? Because it doesn't have an answer. We can finish this question and then continue from here.
Okay.
What do the rest think for this?
Yeah, true.
Yeah, we can just finish this question, then resume at 8.
Yeah, I feel we should bring an end to this question because then it will waste more time at 8 o'clock. Okay, I think we'll just start this question and then we'll see later. And then we'll continue from here at 8. Yeah. Thank you guys. Enjoy your